correct answer is that using a dimmer results in paying less money. When a dimmer is used to reduce the amount of light emitted from a light fixture, there is a corresponding reduction in the amount of electricity consumed by the fixture. The underlying principle involves the dimmer's ability to regulate the flow of electrical current to the light. As the dimmer reduces the current, it consequently lowers the power consumption of the light fixture. Power consumption is quantified in watts, while electricity usage is measured in kilowatt-hours. Therefore, by dimming a light fixture, the kilowatt-hour consumption is decreased, leading to a reduction in the electric bill. To understand the energy savings achieved through dimming, it is crucial to grasp the relationship between voltage, current, and power. Voltage is the electrical potential difference that drives the current through a circuit. Current, measured in amps, represents the rate of flow of electrical charge. Power, measured in watts, is the rate at which electrical energy is transferred or consumed. The relationship between these three quantities is described by the formula power equals voltage multiplied by current. In the context of a light fixture, the power consumed determines the amount of light produced. When a dimmer is introduced, it effectively reduces the voltage applied to the light bulb. This, in turn, reduces the current flowing through the bulb. Because power is directly proportional to both voltage and current, a decrease in either of these quantities results in a decrease in power consumption. It is important to note that the type of dimmer used can impact the efficiency of the energy savings. Traditional dimmers, known as resistive dimmers, dissipate excess energy as heat. These dimmers work by introducing resistance into the circuit, which reduces the voltage applied to the light bulb. However, the energy dissipated as heat is essentially wasted, reducing the overall energy savings. More modern dimmers, such as solid-state dimmers, are more efficient. These dimmers use electronic components to rapidly switch the current on and off, effectively reducing the average voltage applied to the light bulb. Solid-state dimmers waste less energy as heat, resulting in greater energy savings compared to resistive dimmers. Another factor that influences energy savings is the type of light bulb being dimmed. Incandescent light bulbs are notoriously inefficient, converting only a small percentage of the electrical energy they consume into light. The majority of the energy is wasted as heat. When an incandescent bulb is dimmed, the energy savings are relatively small because the bulb is still inefficient even at lower light levels. Compact fluorescent lamps and light-emitting diode bulbs are significantly more efficient than incandescent bulbs. They convert a much larger percentage of electrical energy into light, with less energy wasted as heat. When these types of bulbs are dimmed, the energy savings can be substantial. Furthermore, some compact fluorescent lamps and light-emitting diode bulbs are specifically designed for dimming and offer improved dimming performance compared to standard bulbs. To maximize energy savings when using dimmers, it is recommended to use solid-state dimmers with energy-efficient light bulbs such as compact fluorescent lamps or light-emitting diode bulbs. This combination provides the greatest reduction in electricity consumption and the lowest electric bill. In addition to the energy savings, dimmers can also offer other benefits. Dimmers allow for greater control over the ambience of a room. By adjusting the light level, one can create a more relaxed or more stimulating environment. Dimmers can also extend the life of light bulbs. When a light bulb is operated at a lower voltage, it experiences less stress and lasts longer. This can save money on replacement bulbs over time. Furthermore, dimmers can be used to reduce glare. By reducing the light level, one can minimize the amount of glare reflected from surfaces, making it easier to see and more comfortable to be in a room. From a practical perspective, the actual energy savings achieved through dimming will depend on several factors. These factors include the amount of time the lights are dimmed, the extent to which they are dimmed, the type of dimmer used, and the type of light bulb being dimmed. To estimate the potential energy savings, one can use an energy consumption calculator. These calculators typically require information about the light fixture, the dimmer, and the usage patterns. The calculator will then provide an estimate of the energy savings and the cost savings. Consider a scenario involving a 100-watt incandescent light bulb that is dimmed to 50% of its original brightness for 2 hours per day. If the cost of electricity is 15 cents per kilowatt hour, the energy savings can be calculated as follows. Firstly, calculate the power consumption of the bulb at 50% brightness. Assuming that the power consumption is proportional to the brightness, the power consumption at 50% brightness would be 50 watts, or 0.5 kilowatts. Secondly, calculate the energy consumption per day. The energy consumption is equal to the power consumption multiplied by the time the bulb is dimmed. In this case, the energy consumption would be 0.5 kilowatts multiplied by 2 hours, which equals 0.1 kilowatt hours. Thirdly, calculate the cost of the energy consumption per day. The cost of the energy consumption is equal to the energy consumption multiplied by the cost of electricity. In this case, the cost would be 0.1 kilowatt hours multiplied by 15 cents per kilowatt hour, which equals 15 cents. Fourthly, calculate the annual cost savings. The annual cost savings is equal to the daily cost savings multiplied by the number of days in the year. In this case, the annual cost savings would be 15 cents multiplied by 365 days, which equals $5.48. This calculation demonstrates that even with a relatively inefficient incandescent light bulb, dimming can result in significant energy savings over time. With more efficient light bulbs, the energy savings would be even greater. It is important to remember that these are just estimates, and the actual energy savings may vary depending on the specific circumstances. Nevertheless, dimming is a simple and effective way to reduce energy consumption and lower electric bills. In addition to the cost savings, dimming can also contribute to a more sustainable lifestyle. By reducing energy consumption, one can reduce their carbon footprint and help to protect the environment. Dimmers are a valuable tool for anyone who wants to save money, improve the ambience of their home, and reduce their environmental impact. From an installation perspective, dimmers are generally easy to install and can be retrofitted into existing light fixtures. However, it is important to follow the manufacturer's instructions carefully and to ensure that the dimmer is compatible with the type of light bulb being used. Some light bulbs, such as certain types of compact fluorescent lamps, are not dimmable and can be damaged if used with a dimmer. It is also important to consider the wattage rating of the dimmer. The dimmer should be rated to handle the total wattage of the light fixture. If the wattage of the light fixture exceeds the dimmer's rating, the dimmer can overheat and fail. Furthermore, it's beneficial to use a dimmer that has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, to ensure its safety and performance. When selecting a dimmer, there are several factors to consider. These factors include the type of dimmer, the wattage rating, the style, and the features. The type of dimmer will depend on the type of light bulb being used and the desired level of energy savings. The wattage rating should be sufficient to handle the total wattage of the light fixture. The style should complement the decor of the room. The features may include things like a dimming range adjustment, a preset dimming level, and a remote control. From an electrical code point of view, dimmers must be installed in accordance with the National Electrical Code and local electrical codes. These codes specify requirements for wiring, grounding, and overcurrent protection. It is important to consult with a qualified electrician to ensure that the dimmer is installed safely and correctly. Moreover, dimmers should be installed in a dry location. Moisture can damage the dimmer and create a shock hazard. Additionally, dimmers should be installed in a location where they are easily accessible for maintenance and repair. The energy savings achieved through dimming can also be enhanced through the use of other energy-saving strategies. These strategies include turning off lights when they are not needed, using natural light whenever possible, and upgrading to more energy-efficient appliances. By combining dimming with these other strategies, one can significantly reduce their energy consumption and lower their electric bill. Also, consider using occupancy sensors to automatically turn off lights in unoccupied rooms. These sensors can further reduce energy waste and save money. Similarly, daylight sensors can be used to automatically dim lights when natural light is available. Daylight sensors can adjust the light level to maintain a consistent level of illumination while minimizing energy consumption. It's worth noting that some utility companies offer rebates for the purchase and installation of energy-efficient dimmers and light bulbs. These rebates can help to offset the initial cost of the dimmers and light bulbs and make them even more attractive from a financial perspective. Check with your local utility company to see if they offer any rebates. When evaluating the potential energy savings of dimming, it is important to consider the payback period. The payback period is the amount of time it takes for the energy savings to offset the initial cost of the dimmer. The payback period will depend on the cost of the dimmer, the energy savings, and the cost of electricity. In some cases, the payback period may be relatively short, making dimming a very attractive investment. In other cases, the payback period may be longer, but the long-term energy savings can still be significant. In the long run, dimming is a sustainable and cost-effective way to reduce energy consumption and lower electric bills. By using dimmers effectively, one can create a more comfortable and energy-efficient home. Dimmers are a valuable tool for anyone who wants to save money, improve the ambience of their home, and reduce their environmental impact. Remember, the key to maximizing energy savings is to use solid-state dimmers with energy-efficient light bulbs and to dim the lights whenever possible. By following these simple tips, you can significantly reduce your energy consumption and lower your electric bill. Always consult with a qualified electrician before installing or modifying any electrical wiring or devices. In conclusion, using a dimmer to reduce the amount of light from a light fixture does indeed reduce the amount of energy consumed, resulting in lower electricity bills. The extent of the savings depends on the type of dimmer, the type of light bulb, and the usage patterns, but the principle remains the same: reduced light output translates to reduced energy consumption.